Hey guys, let's talk about force and weight today. This should be a pretty quick lesson, and then you should be able to go ahead and do your online simulations and possibly even get into the lab today. So today we're going to explain the difference between weight and mass and calculate mass from weight or weight from mass. Our terms are mass, force, weight, newtons, and pounds. And these are our equations, and we'll talk about them a little more in the lesson. Isaac Newton was the first person to explain why objects move the way they do, and he looked at two concepts, mass and force. All matter has mass and takes up space. Mass is the amount of matter it is. Everything has mass. A solid rock, gases, and liquids all have mass. The SI unit for mass is kilograms. So for example, we have this image of a 2 kilogram mass. Force is a push or a pull. Forces cause an object to change its motion, and some examples of are weight, friction, tension from a rope, force from a spring, such as the projectile launcher, and electric force. We measure force in newtons. A newton is the amount of is the force required to change the velocity of a 1 kilogram mass by 1 meter per second in 1 second. That's a lot. 1 newton is 1 kilogram meter per second squared. Weight is the force of gravity acting on an object with mass. So how is weight different from mass? Mass is an intrinsic property. It doesn't matter where you go in the universe, your mass doesn't change. However, weight is an extrinsic property. It depends on where you're at and how gravity is acting on you, all right, to determine your weight. Mass is scalar. It has no magnitude, where weight is a vector. On Earth, all right, that vector always points straight down towards the Earth's center. Weight is the force of gravity acting on objects with mass. So the equation, the force of weight is mass times g, or the strength of gravity. And the strength of gravity on Earth is 9.8 newtons per kilogram. 1 kilogram of mass weighs 9.8 newtons, as shown here through this mathematical calculation. Force is a vector, so it has a direction pointing straight down towards the center of the Earth. Now, what happens if you move this to the moon? On the moon, the force of gravity is 1.62 newtons per kilogram. So therefore, on the moon, it would weigh 1.6 newtons. A pound is an English unit of force, all right? So a person is standing on a scale, is pushing down with a force of 125 pounds. A newton is a smaller unit of force than a pound. 1 pound is equal to 4.448 newtons, or 1 newton is equal to 0.225 pounds, or about 3.6 ounces. We can use those conversion factors to calculate somebody's mass in kilograms. First, we're going to find how many newtons they are. Here we calculated taking 125 pounds to newtons, using that conversion factor to give us 556 newtons. We're going to rearrange our equation, all right, and calculate the number of kilograms, right, because mass equals force over gravity, which gives us 56.7 kilograms. Whenever you need to know the force or the weight based on the mass, you can use this first equation. Whenever you need to know the mass based on the weight, you can use this second equation. They are the same equation, simply reorganized. So, if you take a trip from the Earth to the moon, which statement below is correct? Why don't you pause the movie, read the answers, and pick the best statement. Hopefully you've paused this lesson and you have selected B. B is the correct answer. This dumbbell is 10 kilograms in mass. How much does it weigh in newtons? We're going to use our equation F equals m times g. Take a second to solve that. Pause the video. And you'll find out that this weighs 98 newtons based on that mathematics. A person weighs 150 pounds. Let's first find their weight in newtons. So first I'm going to use that conversion factor of 1 pound equals 4.448 newtons. So go ahead and do that math. Give you 667 newtons. Now, using m equals force over gravity, I can find their mass in kilograms. Take a second to solve that. You should get 68.1 kilograms. I look forward to seeing you guys in class again. Bye.